Oh, there you go.
Oh no, no, you see. So I don't know what happened with the internet recently. Actually, in the last 2 days. Yesterday was terrible. Good thing I don't need to. I didn't need to. I don't need to teach. Okay, so part A, which we did last time, was converting from polar. Oh, it's spectrum. I heard spectrum really terrible. Converting. I should say spectrum is really terrible recently. You know. Well, last time we did converting polar to and from rectangular coordinates. That's what we did last time. Okay, now today we will convert polar to rectangular equation. Okay, that's what we will do today. I will start with number 16. Actually, instead of doing it that way, let me do the common polar equations. I don't think you want to memorize that. Of course, if you can, that would be great. But if not, at least you take a look on the habit or the tradition or what's that, what we get used to do. Okay, here's the thing. The first common polar equation, when r equals to constant, what will that be? For example, r equals to 3. Pictorially, that's the coordinate in polar whose distance from origin is 3. Right? So it is a circle centered at origin with radius 3. Now the thing is, again, we thought that radius always has to be positive, but in polar, the radius may be negative. Okay, now the thing is, how do we then convert this into polar, this from polar equation to rectangular equation? R equals to 3, we square both sides, but r squared is x squared plus y squared. Okay, now that's for r equals to constant. Now how about theta equals to constant? For example, when theta equals to pi over 3. What happened with this? I'm sorry, I really don't know what happened with this. Okay, pi equals to, theta equals to pi over 3. So that's the angle theta to be pi over 3. So it will give us a line, right? But can we describe the equation of that line using rectangular equation? The way we do it, I will apply tangent. y tangent theta, because that's the ratio of y over x. So y equals to square root of 3 of x. Okay. In fact, we can say something further, something important that I thought, I said this in my pre-calculus class. The following, that the slope of a line, the slope of the line, let's say m is the slope. Okay, now that slope is rise over run, right? That's rise over run. You see what I mean? y2 minus y1 over x2 minus x1. Now notice that that's actually the ratio for tangent of that theta. You see what I mean? So suppose we have a question like this. So this is a side example. Suppose I have find the angle of line y equals to 2x minus 1 to x-axis. To be more precise, positive x-axis. Solution. Now we know the slope is 2, which is equals to tangent theta. Okay, so the angle will be tangent inverse 2. Does it make sense? This is supposed to be pre-calculus material though, not calculus 2. In other words, you're supposed to know this already. Okay, now the thing is, like, I don't think pre-calculus, most pre-calculus instructors don't go over this. Now, why I want to mention this, because suppose you have find another example, find the angle between line 1 y equals to 2x minus 1 and line 2 y equals to negative 3/4 x plus 7. Then the slope for the first line is 2. The slope for the second line is negative 3/4, right? Call this tangent of theta 1. Call this tangent of theta 2. So the angle to positive x-axis will be tangent inverse 2 for theta 1. And for theta 2, that will be tangent inverse negative 3/4. So one of them is 2x minus 1. The other one is negative 3/4 x plus 7. This is line 2. Okay, now then can you find the angle between these two lines? Okay, now notice that this is our theta 1. This is our theta 2, right? Actually, to be more precise, this is our theta 2. Okay, so the angle will be the sum of these two. To be more precise, the angle theta here will be theta 1 minus theta 2. That is tangent inverse of 2 minus tangent inverse of negative 3/4, which is tangent inverse 2 plus tangent inverse 3/4. Okay. Well, that's about theta equals to constant. So if the R is constant, what happened? When the theta is constant, what happened? R is constant, give you a circle. Theta is constant, give you a line going through the origin. Third, what if x equals constant? That's a rectangular equation. Okay, for example, x equals to, let's say, -4. What will the polar equation be? I replace Rx by R cosine theta. Now, it is a custom that if we have polar equation, we solve for R. We have R by itself on one side. Okay. Now, likewise, if, let me call this part A. So when y equals to constant, what happened? Y equals to 3, let's say. So R sine theta, that's y, equals to 3. So R equals to 3 cosecant theta. What happened if we have even more general case like, let's say x plus y equals to constant. Let's say x plus y equals to -5. This is R cosine theta plus R sine theta equals to -5. Factor the R. So R is equals to -5 over cosine theta plus sine theta. We can simplify that further though. Okay, we can simplify that further, but not always, simply. It just happened in this case, I can simplify that further. Some side note. Cosine theta plus sine theta is equal to square root of 2 sine theta plus pi over 4. How do you get that, Thomas? I need to set some time for that, but this is actually trigonometry. And pre-calculus. Basically, maybe I explain it then. I explained that then. So you see, like for me to explain polar coordinate system, I need to go very deep into trigonometry, even to the part that our pre-calculus or trigonometry instructors didn't cover. Okay, what I have here is something called condensation method. You know what? Let me talk about this in separate page. Because this is quite important. This is quite important. It is important for your, especially if you are going to signal processing, condensation method. it is to condense the expression A cosine theta plus B sine theta to C sine theta plus something. Okay, that's what we will do here. Suppose I have A cosine theta plus B sine theta. What will that be in a single sign? Now, little insight. Okay, suppose I have y equals to 3 cosine theta plus 4 sine theta. One of the big question is, can you find the range of this function? What is the range of this function? Now, you may think that the maximum for 3 cosine theta is 3. The maximum for 4 sine theta is 4. So the range will be up to 7. No, that's not true. That's not true. Okay, the range is actually from -5 to 5. Now, how do we find the range? Is we can only find it after we condense this. Okay. Now, I will start from the right-hand side actually. Let C sine theta plus some angle be equals to C times sine theta cosine alpha plus cosine theta sine alpha. So this is C times sine alpha cosine theta plus C cosine alpha sine theta. Now I match it with A cosine theta plus B sine theta. From here you see this is my A and this is my B.
I think the first alpha should be.
Oh, I switched it. This guy becomes this. This guy becomes this.
Oh, then the second cosine will be a theta, right?
Yeah. Okay. Now then, so A equals to C sine alpha and B equals to C cosine alpha. So suppose I know the A and B, what will my C be? Okay, notice that A squared plus B squared equals to C squared sine of squared alpha plus C squared cosine squared alpha. But that's basically C squared. Okay, so C will be square root of A squared plus B squared. That's one. Second, I want to scroll this down, but I wonder why I don't get this. Second, notice that if I divide what happened? when I divide B, I'm sorry, A over B, if I divide A over B, I will get C sine alpha over C cosine alpha. That's tangent alpha. I want to go down, but I cannot. What happened? Now I see. Okay, so we can say that tangent alpha equals to A over B. Now we need to be careful not to say that alpha equals to, but it is equivalent to tangent inverse of A over B. Need to adjust the alpha. Now let's do an example. Suppose, for example, the one we have earlier, y equals to cosine theta plus sine theta. So notice that my A is 1, my B is 1, right? A is the coefficient of cosine. B is the coefficient of sine. So C is square root of 1 squared plus 1 squared. That's square root of 2. At this point, we can say y is equals to square root of 2 sine alpha plus sine theta plus something. Now, then tangent alpha will be 1 over 1. 1 for the y, 1 for the x. So the angle alpha is 45 degrees. So this is y equals to square root of 2 sine theta plus pi over 4. Okay, so you see then, if somebody asks you, okay, what is the range of cosine theta plus sine theta? What's the range? No, you see that this is equals to square root of 2 sine something. Right? So the range will be, the maximum is radical 2, the minimum is negative radical 2. Okay? Now that I use simple example though. Let me do one more example. This is trigonometry, by the way. Let's say I have y equals to, let's say, square root of 3 cosine theta minus 2 sine theta. So my c is square root of radical 3 squared plus negative 2 squared. That's 3 plus 4, that's square root of 7. But how about the angle? Tangent alpha will be dA over the B. But let's see the position first. The y is negative radical 3, the x is negative 2. So it's like this. So the angle is 5 pi over 6. Because the coordinate is, the y is radical 3, the x is negative 2. Oh, hold on. No, it's not. That's tangent. I'm sorry. I'm sorry. No, this is not. This is not. Okay, so the alpha here will be in quadrant 2. Okay. Now, if I use calculator, alpha equivalent to tangent inverse of negative radical 3 over 2. Give me a second. I will make it in degrees. I get, this is negative 40 something. But alpha is supposed to be in quadrant 2. So alpha equals to that angle plus 180 degrees. Because the angles we get, negative 40 is here. So I add 180 degrees to get the actual alpha, which is 139.11 degrees. So this y will have, the amplitude is radical 7 sine theta plus 139.11 degrees. Okay, that's a little example of that condensation. Let me go back. That's for x and y constant, what will happen? So suppose, for example, I start working on number 16. We have r equals to 4 secant theta. What will that be in rectangular coordinate system? That's r equals to 4 over cosine theta. R cosine theta equals to 4. So x equals to 4. Mickey Mouse. How about number 18? What happened if theta equals to pi over 3? We did this a lot. We did this earlier. So apply tangent to both sides. Tangent theta is y over x equals to radical 3. So y equals to radical 3 of x. Number 20. R equals to tangent theta secant theta. So R equals to, tangent is cosine theta over cosine squared theta. Ooh. Okay, so this is r cosine squared theta equals to sine theta. How do we make it into x and y? I'm missing one r here. I'm missing another one r on the right-hand side. So multiply both sides by r. So I get r squared cosine squared theta equals to r sine theta. So I get x squared equals to y. Number 22. Y equals to x. This is r sine theta equals to r cosine theta. So we get tangent theta equals to 1. Or simply theta equals to pi over 4. How about number 24? 4y squared equals to x. This is 4r squared sine squared theta equals to r cosine theta. Cancel the r. So I get r equals to cosine theta over 4 sine squared theta. So that's 1/4 cotangent theta cosecant theta. Again, we usually try to solve for r. Not all the time, but if possible, your polar equation is r equals something. Number 26, xy equals to 4. This is r cosine theta, r sine theta equals to 4. So r squared equals to 4 over cosine theta sine theta. Do you think you can simplify this even further? So r squared equals to 8 over sine 2 theta. So r squared is 8 cosecant 2 theta. Okay. Now, I will do next the one with Limachon. The following are the more important one, not usually covered in lower level, except when you are in my trigonometry class. The following. R equals to A plus B sine theta, or R equals to A plus B cosine theta. Those are the general form. Let's first talk about when A equals to 0. So we will be talking about B sine theta, or R equals to B cosine theta. Some note. If you feel I'm going fast, that's because I'm doing review from pre-calculus and trigonometry. Note. If R depends on sine theta only, no cosine theta, then the graph has y-axis symmetry. So as you will see, the one here, this guy here, will have y-axis symmetry. Okay. Now, on the other hand, if R depends on cosine theta only, then the graph has x-axis symmetry. So this guy here will have x-axis symmetry. Now I will do it by example. Let's say the one here. What is the rectangular equation? Let's say R equals to 4 sine theta. What I will do, I will multiply both sides by R. So on the left-hand side, I get x squared plus y squared. On the right-hand side, I get 4y. Then from there, I do completing the square. What do I need to add to complete the square on the left-hand side? I need to add 4, right? So I get x squared plus y minus 2 squared equals to 2. I mean 2 squared, which if we picture that, that is a circle centered at 0, 2 with radius 2. And at least this confirms that this graph is symmetric with respect to y-axis. Okay. Now you can generalize this actually by saying the following. R equals to b sine theta will give us a circle centered at 0, b over 2, and the radius is b over 2. Okay, you will see likewise for r equals to b cosine theta, that will be a circle centered at b over 2, 0 with radius b over 2 as well. Okay, the graph will look like this. The thing is, what happens if the A is not 0 for A greater than B? R equals to A plus B sine theta. R equals to A plus B cosine theta. The rectangular equation is so hard to get, but at least I want you to get the graph. Okay, I need you to get the graph. Let's say, for example, R equals to 3 plus 2 sine theta. What will the graph look like? Now we know this graph will be, the graph here will be symmetric with respect to y-axis. Okay, it will be symmetric with respect to y-axis. Why? Because this R depends on sine theta only. Now, so what we will do, we will graph the left-hand side only. Okay, I will graph the right-hand side only. When theta equals to 0, that will be 3. When theta is 0, the R is 3. When theta is pi over 2, the R is 5. But when theta equals to negative pi over 2, that's 1. So you will see the graph look like this. And I copy that to the left-hand side. Okay, suppose I have R equals to 4 plus 3 cosine theta. Now we know it will be symmetric with respect to x-axis. When theta equals to 0, that's 7. When theta equals to pi over 2, that's 4. When theta equals to pi, that's 1. So I will graph the top part and copy paste that, reflect that below. Okay, now let's see the actual graph first, so that you have a feeling on what we do here. Give me a second, I get my graphing software. So R equals to, give me a second. R equals to 3 plus 2 sine theta. That's what it looks like. Okay, you know what? Let me screenshot that and put it on my graph. And then the other one is R equals to 4 plus 3 cosine theta. Now, what happens if the A is equal to B? Try to imagine this. So R equals to A plus B sine theta, right? Because A is equals to B, then the maximum will be twice, right? The maximum will be A plus B, but the minimum will be A minus B, which is 0. Okay, you see that this will be at most A plus B, at least A minus B, correct? Okay, now if A equals to B, then that will be 0 here. In other words, there will be a theta where the graph intersect the origin. Okay, let's say, for example, R equals to 2 plus 2 sine theta. When theta equals to 0, that's 2. When theta equals to pi over 2, that's 4. But when theta is negative pi over 2, that's 0. So the graph will look like this. Okay, but it goes through the origin. We have a cusp at origin, but no loop. No loop. Now, under what situation we have a smaller loop? It's when the amplitude of the part is greater than the constant. So for example, if I have y equals to 3 plus 4 cosine theta, when theta equals to 0, that's 7. When theta is pi over 2, that's 3. But when theta equals to pi, that's negative 1. So it actually looks like this. That's what it looks like. Okay, and then because it's symmetric with respect to x-axis, then the mirror will look like that. Okay. Notice that I only do the sketching. Okay, later on in 10.4, we will do more details. But let's do the graphing first. Let me give the graph. Give me a second. You see if the radius is the constant and the coefficients are the same, then it will touch the origin without any loop. without inner loop. Okay, but if the coefficient is greater than the constant, then we will have inner loop. Now, my emphasis will be, I need you to have a feeling of what will happen if you have these ones. What happened if the A is 0? Oh, that's easy. That will be a circle. What happened if the A is smaller than B? Then you have a loop, smaller loop. If they're the same, then no more loop. Okay, now if the constant is larger, then it becomes what we call limachon. There's no loop, not even touching origin. Okay, no loop, not even touching origin. Okay, now we have more. Sorry, I basically throw at you these things. Another type is on roses, they call that. That's R equals to a constant sine n theta, or R equals to a cosine n theta. You will see that these A here are the radius of the flower of the roses. Because this is sine, then you have symmetric with respect to y-axis. And cosine, it will be symmetric with respect to x-axis. Okay, now let's see some graphs. And we will try to get some, how to say that, summary from there. Okay, give me. I kind of like brainstorming you. Okay, but I hope by seeing some examples, you can actually graph that faster later on. 2 theta. I want to say that to see the radius even better, let me make it 3. So you see that's the radius 3. Right, let me screenshot this and put it in our notes. If I change this to 4 theta, that's what it looks like. What happens if I make it cosine instead? Maybe 2 more where I use the angle to be an odd number, 3 theta. What if I have 5 theta? Thomas, you just give us all the graphs, but you don't really explain it. I'm about to explain it now. Now, this one here is, this is 3r equals to 3 sine 2 theta. Notice that 3 sine 2 theta has radius 3, right? You can see that all of these flowers here, all these roses here actually has radius 3, right? Okay, now, when the theta is even, you will have 4 leaves. I'm sorry, I should say, if the theta is even, then the number of leaves is twice of that. So you see these 3 here give us the radius. Radius of the flower is 3. Number of leaves is 2 times double the 2, if that's even. Now, how do we know that this is sine or cosine, Thomas? Because this is symmetric with respect to x-axis, also symmetric with respect to y-axis. Well, just try it. Okay, you have the option r equals to 3 sine 2 theta or r equals to 3 cosine 2 theta, right? How do we know it's sine and not cosine? Well, it's not cosine because when you plug in theta equals to 0, what happened? When theta equals to 0, the r will be 3. When theta equals to 0, the r 3. So you're supposed to have a coordinate there, but you don't. So it won't be cosine. Does it make sense? So it must be sine, right? Okay, now how about this one here? The radius is 3, so r equals to 3 something. Is it sine or cosine? There is no coordinate at 3, 0, so it must be sine. It must be sine. Something theta. How many leaves? 1, 2, 3, 4, 5, 6, 7, 8. Because there are 8 leaves, which is even, then the angle must be 4 theta. Because that's even, then the coefficient will be 2 times 4. How about this one? The one on the left, r equals to 3. Is it sine or cosine? Oh, we have a coordinate at 3, 0, so it must be cosine. Cosine how many thetas? Let's see how many leaves. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 leaves, so the n must be 4. The radius is 3 here. It's sine or cosine? Or we have a coordinate at 3, 0, so it must be cosine. How many leaves? There are 3 leaves. If the number of leaves is odd, then that is the coefficient of the angle. Okay, so like this one here, the radius is 3. You have a coordinate at 3, 0, then it must be cosine. How many leaves? 1, 2, 3, 4, 5. There are 5 leaves, which is odd. So the angle must be 5 theta. Okay. That's a very fast crash course, huh? Now we have a lot more graphs in polar though. We have a lot more graph in polar. Yeah, we have a lot more graphs in polar. Now, let's go on. The calculus or the analysis of polar curve. After bombard ourselves with those polar equations and polar graph, let's take a look on tangent curve. Tangent to polar curves. We know that x equals to r cosine theta. The y equals to r sine theta. Okay, now so think of this x as and y to be functions of theta. Okay, so dx dy, I'm saying dx d theta will be the derivative of r cosine theta respect to theta. Now don't forget r is a function of theta. So this will be product rule dr d theta times cosine theta plus r times negative sine theta. While dy d theta will be the derivative of r sine theta respect to theta. This will be dr d theta sine theta plus r cosine theta. Okay, so dy dx, if you remember our parametric equation thingy, okay, so dy dx basically the ratio of those. Dr d theta sine theta plus r cosine theta over dr d theta cosine theta minus r sine theta. Now it seems to be complicated, but it's actually a lot easier than that. Now, for example, if you need horizontal tangent line, then your dy d theta has to be 0, but your dx d theta is not. But that has something to do with what we learned in parametric tangent line, okay, 10.2. Okay, likewise, vertical tangent line is when dx d theta equals to 0, but dy d theta is not. Now, what if both of them 0? Then approach that using limit. Okay, I will do some problems from here and then we go to 10.4. I think I want to do number 56. r equals to 2 minus sine theta. Theta equals to pi over 3. The question is find the slope of tangent line to the given polar curve at the time at the point specified by the value of theta. Basically find the slope of tangent line at theta equals to pi over 3. How do we do that? Let's see what's our x first. What is our y? Our x is r cosine theta, right? But this is, the r is 2 minus sine theta. So dx d theta will be negative cosine theta times cosine theta plus 2 minus sine theta times negative sine theta. While y is r sine theta. So dy d theta equals to negative cosine theta times sine theta plus 2 minus sine theta cosine theta. Fast forward, this is 2 cosine theta minus 2 sine theta cosine theta. I think I can simplify that though, but I'll do it later. Should I do it now or later? I do it now. This is equal to negative 2 sine theta minus cosine 2 theta. While this one here is 2 cosine theta minus sine 2 theta. Not that we need it, right? Okay, but the question is then find the slope when theta equals to pi over 3. Right? That's the question. Now, instead of computing it in there, let's do the component. So dx d theta when theta is pi over 3. That will be negative 2 sine pi over 3 minus cosine 2 pi over 3. What's that? Negative radical 3 plus 1/2. And this guy here, dy d theta at theta equals to pi over 3, I get 2 cosine pi over 3 minus sine 2 pi over 3. That's 1 minus radical 3 over 2. So with these two here, then I go here. You know what? Let me change the ordering. Give me a second. Do it later. So it's better organized. So this is equal to, what is my dy d theta? 1 minus radical 3 over 2, and then the x d theta is negative radical 3 plus 1/2. Multiply the top and the bottom by 2, I get 2 minus radical 3 over negative 2 radical 3 plus 1. You can rationalize, we should rationalize the denominator. Multiply by 2 radical 3 plus 1, 2 radical 3 plus 1. So at the bottom, we'll get 1 minus 12, that's negative 11. While on the top, that will be 4 radical 3 minus radical 3, and then negative 6 plus 2, that's negative 4. So that will be negative 4 plus 3 radical 3. Unless I make miscomputation. But just to find the slope, I actually need to do, from parametric point of view, I need to do this and plug in the angle. I need to do this and plug in the angles, and then get the ratio. Okay, and then get the ratio. Number 62. Find the points on the given curve where the tangent line is horizontal or vertical. Do I want to do number 60? Okay, I do number 62. So r equals to 1 minus sine theta. According to what we know, the graph should look like when x equals to 0 is 1. So it looks like this. That's what it looks like. Okay, so we will have 3 horizontal tangent line and 2 vertical tangent line. We don't know what happened here. Right at that origin, we don't know what happened. Okay, so we need to find the theta with for horizontal tangent line or vertical tangent line. Okay, so x equals to r cosine theta, which is 1 minus sine theta cosine theta. There are many ways to do the derivative here though. One way, the way you did, I showed you earlier, you basically do product rule. Another way, you distribute this first, cosine theta minus sine theta cosine theta. Okay, now, and I try to benefit from here. This is part of the double angle. This is cosine theta minus 1/2 sine 2 theta. Now, hopefully, by doing so, the derivative will be a lot easier to deal with. Okay, so dx d theta will be negative sine theta minus cosine 2 theta, right? A lot easier. So either you fix it first and then do the derivative, or you do the derivative first, then fix it. Either way. Okay, y equals to r sine theta so that's sine theta minus sine squared theta. So the derivative dy d theta equals to cosine theta minus 2 sine theta cosine theta. Okay, we will start with horizontal tangent line. Horizontal tangent line when dy d theta is equals to 0. So we cannot go too far from trigonometry. Huh? How do we solve this trigonometric equation? Factor cosine theta. Okay, so cosine theta equals to 0 or sine theta equals to 1/2. Cosine theta equals to 0 when theta is pi over 2 or 3 pi over 2, is it right? Sine equals to 1/2 when theta is pi over 6 or 5 pi over 6. Now check this again, dx d theta. Okay, dx d theta, we have seen that's negative sine theta minus cosine 2 theta, right? Okay, so check against this at pi over 2. That's negative 1 plus 1, huh? That's 0. So we will have issue at pi over 2. At theta equals to pi over 2, we have dy d theta equals to dx d theta equals to 0. We will take care of that later on. Okay, need to check further. You know what, let me just do it now. Limit theta going to pi over 2 of dy dx cosine theta minus 2, I'm sorry, cosine 2 theta over negative sine theta plus cosine 2 theta. When theta approach pi over 2, what will the result? If you just plug in pi over 2, you will get 0 over 0. So what do we do? L'Hopital rule maybe? Will that help? Let me check by plugging numbers. This will be -1 minus 2 times -1 over, this will be 0, this will be 0. So that's undetermined. So let's approach that slower from positive side. From positive side, that will be positive infinity. When we do limit theta goes to pi over 2 from the negative side, actually this is negative infinity. You figure out yourself, okay? You figure out yourself. This will be negative infinity. And when you approach from negative side, that will be positive infinity. So it's actually a vertical tangent line at theta equals to pi over 2, not horizontal tangent line. Now that's only for the first case though. That's only on the first case, which we did expect happen will be an issue earlier. Remember when I sketched this graph? This is when theta equals to pi over 2, right? So if I enlarge that later on, you will see that it's actually look like this. There's a vertical tangent line at pi over 2. Okay, but the rest will be a horizontal tangent line, as we expect. But we check, of course, not only rely on our visual, right? So dx d theta at 3 pi over 2, that will be negative sine 3 pi over 2 minus cosine 3 pi. This will be 1 plus 1, that's equals to 2, that's not equals to 0. So dx d theta at pi over 6. It's negative 1/2 minus 1/2, that's negative 1, that's not 0. At 5 pi over 6 will be the same. Okay, so horizontal tangent line at theta equals to pi over 6, theta equals to 5 pi over 6, and theta equals to 3 pi over 2. That's only horizontal tangent line. How about the vertical tangent line? We need to set the dx d theta to be 0. How to solve that? This is 1 minus 2 sine squared theta plus sine theta. Oh, sorry, this is 0. I will factor it. Should be plus here, minus here. And you find out how to factor it. Okay, so we get sine theta equals to 1 or sine theta equals to -1/2. Notice that we would have at least 2 vertical tangent lines. One of them here, another one here, and earlier we found out that we have vertical tangent line here, right? Okay, so theta is equal to pi over 2 or theta equals to -7 pi of, 7 pi over 6, 11 pi over 6. Now check against dy d theta. Later on, I will show you a better organization way to do this. 2 cosine theta and then sine 2 theta. 2 cosine theta minus sine 2 theta. Is it right? Cosine theta minus 2 minus sine 2 theta. Eh? Wait. Give me a second. dy d theta, where's my dy d theta? This guy. Right? This is my dy d theta. Why do I have 2 there? No 2 here. So we already checked dy d theta at pi over 2, that's equals to 0. That's the issue we have earlier. At 7 pi over 2 over 6, that's negative radical 3 over 2 minus sine, that's radical 3 over 2, that's negative radical 3, which is not 0. Cosine 11 pi over 6, that's radical 3 over 2 positive minus minus 6, that's 5 pi over 3 pi over 3 radical 3 over 2, so that's positive. So vertical tangent line at x, theta equals to pi over 2, theta equals to 7 pi over 6, theta equals to 11 pi over 6. I'm about to give myself a break, but let me show you this. A lot of things is done here. Notice that the way I did it is we tried to see it from a bit far away. So what I did was I found d theta, dx d theta, and dy d theta. Oh no, that's the previous question. I look at the wrong question. Sorry. This one here. I get dx d theta and dy d theta. Okay, then I try to observe horizontal tangent line. I get these 4 angles where dy d theta equals to 0. And I try to confirm that the dx d theta is not 0. We have issues right away on the very first one. And then I do vertical tangent line. Now, what I will do next, later on, I will do it in different order. Let me tell you first what I will do. A better organization. So this is what we will do. So we will get given r as a function of theta, find dx d theta, and solve dx d theta equals to 0. But do not check yet. Do not check that right away. Don't check that right away. And then after that, you do dy d theta and solve dy d theta equals to 0. Now from here, you will get a lot of thetas, right? Like for example, we'll get thetas pi over 2, theta equals to 7 pi over 6, theta equals to 11 pi over 6. From here, we get theta equals to pi over 2, 3 pi over 2, theta equals to what? Pi over 3, is it right? Pi over 6. So you list the thetas first, where dx d theta is 0, dy d theta is 0. Now from this list, you see the following. We are safe for this guy. We are also safe for this guy. Right? So we can say it right away. Vertical tangent line at theta equals to 7 pi over 6, theta equals to 11 pi over 6, horizontal tangent line at theta equals to 3 pi over 2, theta equals to pi over 6, theta equals to 5 pi over 6. Need to analyze at theta equals to pi over 2. That's the problem. So you solve for each one of them first. That's actually a better way to do that. So you solve for each one of them. Okay. Now, once you see an angle where that shows up in both of them, like pi over 2 here, then you know you need to approach that using limit condition. But for this guy here, we are safe. Okay. At theta equals to 7 pi over 6, dx d theta is 0, but not dy d theta. Right? Okay, so we can safely say that it is vertical tangent line right away from there. This is the only one we need to observe further. Okay. Okay, in my opinion, this is a better organization to do the problems. So we solve them first and then do the checking later on. And the checking is actually, we don't really do the checking. The only checking we do here will be with the angle that both of them share the same angles. Okay, now I will take a break. We come back at 9:10. Okay, let's start again. Let me do one more problem from this 10.3 before I move on to 10.4. I would like to do number 64. R equals to e to the theta. If you ever wonder what it looks like, what the graph look like when theta equals to 0, that's here, that's 1, r equals to 1, and then it actually gets larger and larger. It approximately looks like this, spiraling. Okay, that's if you start from theta equals to 0 though, but if you don't limit the theta, then it actually goes indefinitely far here. Okay, now then, so what will our x be? X will be e to the theta cosine theta. The y will be e to the theta sine theta. Do the derivative. I factor e to the theta, which will never be 0. Okay, so if I set this to be equals to 0, I will get cosine theta equals to sine theta. But that's only when tangent theta is equal to 1. Is it right? Therefore, theta is equals to pi over 4 plus pi k, where k are integers. Likewise, dy d theta, this is e to the theta sine theta plus e to the theta cosine theta. Now dy d theta will be 0 if sine theta plus cosine theta equals to 0. Because e to the theta can never be 0. We know that the range of e to the theta is positive, right? It never be 0. So from here we see that sine theta equals to negative cosine theta. Tangent theta is negative 1, so theta is negative pi over 4 plus pi k. Well, actually, nothing in common, right? They don't have anything in common. We will have a vertical tangent line at these angles here. vertical tangent line, and horizontal tangent line here. Now let's sketch the graph better. Okay, let's sketch the graph better. E to the theta r equals to E to the theta. Not that interesting so far, but let me make my theta to be, give me a second, to be 10 pi, and this will be negative 10 pi. Let's see. That's what the graph looked like. If I zoom it in, you see, seems like we keep on having something new, right? Let me just use this one here then. Let me use this one here. Oh, too small. How about this? This one. Okay, let me screenshot this. Oh, before I screenshot, let me do this first. I want to put y equals to x and y equals to negative x. Okay, let's screenshot this. Okay, you see that we have vertical tangent line here, and later on also here. When you extend this, vertical tangent line there. On the other hand, the horizontal tangent line here, and also here, if I super zoom it. Okay, here we have horizontal tangent line here. Notice that it intersects this y equals to negative x. That's when the angle is negative pi over 4. You see? Okay. Now that's for 10.3b. It's a long section, I know, but 10.4 will be on the easy side. .4a, I don't think I can finish this. 10.4a is on area in polar coordinates. Now, suppose we have a curve. Let's say this is r as a function of theta. Then how will we find the area? First, we find d theta from the origin. This is the d theta. Now, what is the area here? What is the area here? If the theta is very, very small, if the d theta is very, very small, what end up happening, this becomes very close to an arc of a circle. Now, the area of a sector area from geometry is equal to 1/2 r theta if the angle is theta. This is r. Oh, 1/2 r squared theta, I'm sorry. Okay, so the differential of area here will be equals to 1/2 r squared d theta. The total area, therefore, will be integral of 1/2 r squared d theta. That's it. That's the formula for the area. Okay, of course, from theta equals to A to theta equals to B, right? But that's the formula for the area of a curve in polar. Now let's take a look on number 6 in our textbook. Number 6, do I have the picture? Number 6, I will sketch the graph. Okay, this is the graph here. But we just need the one above the x-axis. We want to find the area here. Where the r is given by 1 plus cosine theta. What is the area? Now, can you tell me what's the theta? From what to what? At this point here, that's when theta equals to 0, right? This is when theta equals to pi over 2. This is when theta equals to pi. Okay, so the theta will be from 0 to pi. That will tell us the limits of integration. If the r equals to 1 plus cosine theta, so what happened to r squared? 1 plus cosine theta being squared. So the area is 1/2 integral from 0 to pi of r squared d theta. That's it. That's the setup. Can you do it yourself or you want me to do this? I do it then. This is 1/2 integral 0 to pi 1 plus 2 cosine theta plus cosine squared theta d theta. This is 1 plus cosine 2 theta over 2 d theta. So this is equals to 1/2 times 3 pi over 2. That's 3 pi over 4. Oh, Thomas, what happened with this? This will be 0. And this also be 0. Why? The graph of cosine looks like this, right? Okay, but from 0 to pi, you have area 1 and -1. So they cancel. While cosine of 2 theta has period pi. Okay, so the area here and here cancels the area here. Now you can do it long way if you want though. Okay, if you want to do it long way, just integrate and then plug in the numbers. Go ahead, go for it. That's for number 6. How about number 8? Slightly more difficult. We have, actually we graphed that earlier. We have r equals to sine 2 theta. We have a loop here. It looks like this, right? Sorry, it looks ugly. But we need just one of the leaf, the one in the first quadrant. Now then, first thing first, we need to find the angle, the limits of integration. What's the limit of integration? Now notice that the loop actually starts from origin, ends at origin. So let's solve for that. Sine 2 theta, which is the r, set it equals to 0. So 2 theta equals to 0 plus pi k, right? So theta equals to 0, right? Every pi, it becomes 0. So this is pi over 2k. So when k equals to 0, theta is 0. When k equals to 1, theta equals to pi over 2. So theta will be from 0 to pi over 2. That will give you one loop. Okay, so the area will be 1/2 integral from 0 to pi over 2 sine square 2 theta d theta. Then we do half angle. But again, the period for cosine 4 theta is pi over 2. So I would say that if you do it long way, you will see that the integral for cosine 4 theta on pi over 2 is 0. So this is equal to 1/2 times 1/2 times pi over 2. That is pi over 8. That's for number 8. How about number 10 or 12? I do number 12. Sketch the curve r equals to 4 plus 3 sine theta and find the enclosed area. What happened, Robert? You cannot see what I'm writing? It's been so long. Nobody tell me. Okay, I was here earlier. I was here. My bad. So I was here. Uh-oh. So this is 10.3b. This is 10.4a. I'm very far already. Number 6. Here, take a look on this first. This is the area for the curve to the origin in polar coordinates. Question for number 6. Always do the interval of integration first and then use the formula. Okay, now in between, be creative. For example, cosine theta from 0 to pi, it looks like this. Now you know the area here and the area here cancels. If you want to do it long way, go ahead. Okay, now I just finished number 8. Again, I need to find the limit of integration. Therefore, I see, oh, what is my theta supposed to be? And I see this loop starts from the radius 0 to radius 0. So I solve for this and get 2 consecutive theta in quadrant 1. Okay, and then once I get the limits of integration, then I get the area. Compute and get the area. Number 12. Sketch and find the area. Find the area it encloses. Four plus 3 sine theta. So when theta equals to 0, that's 4. When theta equals to pi over 2, that's 7. When theta equals to negative pi over 2, that's 1. Because it depends on sine theta only, then it must be symmetric with respect to the y-axis. It will look like this. Sorry. Okay, and we know, again, it's symmetric with respect to y-axis, right? So I will do the following. The area will be 2 times the area on the right. Is it okay? The total area is twice the area on the right. Which is 2 times 1/2 integral from negative pi over 2 to pi over 2 of the radius squared. Oh, that thing cancels. That's nice. I get 16 plus 24 sine theta plus 9 sine squared theta d theta. Is that right? Now then again, sine is an odd function. So if we have opposite or a symmetric domain, then this will become 0, right? Okay, so this will be integral from negative pi over 2 to pi over 2 of 16d theta plus 9 times integral negative pi over 2 to pi over 2 of 1 minus cosine 2 theta over 2 d theta. But again, this will be 0. Okay. Then this will be 16 pi plus 9 over 2 pi. So 4.5, 20.5 pi. I think those are on the easy side. How about the harder one? I don't know how to do this though, to be honest with you. But let's see number 18. Find the area of the region enclosed by one loop of the curve. So r squared equals to sine 2 theta. I don't even know what this look like. Yeah, I don't even know what this guy looks like. But let's set this equals to 0. Yeah, let's set this equals to 0. Yeah, because they say one loop, right? Okay, so we set r to be 0. So 2 theta is pi k. But don't forget, sine 2 theta has to be on the positive side because r squared. R cannot be imaginary. So theta is pi over 2k. So k equals to 0. Theta equals to 0 when k equals to 1. Theta equals to pi over 2. Okay, so the area will be 1/2 integral 0 to pi over 2 of r squared, which is sine 2 theta already. Okay, that's 1/2. That's 1/2 negative cosine 2 theta pi over 2 from 0 to pi over 2. So that's 1/2. I would like to know what it looks like. Let me sketch that and screenshot it there later on. So r squared equals to sine 2 theta. This is what it looks like. How about number 21? The inner loop area of inner loop of r equals to 1 plus 2 sine theta. What it looks like to start with. 3, negative 1. So it looks like this. Oh. That's what it looks like. What we need is the inner loop, but how do we find the angle? Now we have inner loop if the radius negative. Okay, so let's find the R, set R equals to 0 first. So sine theta equals to -1/2. So theta will be in quadrant 3, 7 pi over 6 and 11 pi over 6. That will be the limit of our integration. Okay, so the area equals to 1/2 integral from 7 pi over 6 to 11 pi over 6 of 1 plus 2 sine theta squared d theta. Minus. That will be 3 plus 4 sine theta minus 2 cosine 2 theta d theta. Okay, that's 1/2 3 theta and then -4 cosine theta minus sine 2 theta from 7 pi over 6 to 11 pi over 6. Just continue yourself. Okay, that's just computation, right? I think the more interesting one is question like number 23 to number 28. That will be, I think that will be my last question. Last question that I will do. And then on Wednesday, I will continue a bit more from this 10.4. Which question you would like me to do here? Let's see number 26. Find the area of the region that lies inside the first but outside the second. So inside the first is R equals to 2 plus sine theta. But outside of R equals to 3 sine theta. Can we graph this? Sketch the graph first. So the first one, the inside, I use red color. That will be 2, 3, 1. So it looks like this approximately. Inside of this, but outside of 3 sine theta. 3 sine theta, so it is a circle with radius. Now the things I don't know where they intersect. Maybe something look like this. And if that's the case, then it will be this region. Okay, that will be the region. Inside the cardioid, inside the cardioid limation, but outside the circle. Let's find the intersection. So you set the R equals so 2 equals to 2 sine theta. So sine theta equals to 1. So theta equals to pi over 2, right? They have the same radius here. But from the picture, we see that they intersect at 2 other places. How could that happen? Am I graphing it wrong? No, I don't think so. I think I get it okay. Yeah, I need to find this intersection here. I need to find this one here. Oh, you know what? Maybe the radius are opposite. So this guy happens to be on the opposite side of that. Let's see. Is it possible? Let me sketch the graph first. I'm sorry. In my opinion, it should look like that, but let me sketch the graph first. So R equals to 3 sine theta. That one is easy. And then the second graph is R equals to 2 plus sine theta. Oh no, it's just like that. I'm sorry. So my computation was correct. They intersect only at one point. So outside the circle, but inside the limation. But if so, we can just find the area of the limation minus the area of the circle. Go back. See, my computation shows that this is not correct. Only intersect at here. So the area will be area of the limation minus the area of the circle. Now the area of the limation will be 2 times 1/2 area on the right-hand side. I use the symmetry. Minus the area of the circle, but the radius of the circle is 3/2. Okay, so what I did actually, I get the area here, the area of this limmason, and then I double it minus the area of the circle. You see? Okay, so that's what I did. They happen to intersect only at one point. You can continue with the computation here. Now on Wednesday, what I will do, I will go on with, I think I will do more problems from this area and then go on with the arc length. Now then we will continue with chapter 11, that is 11.1. That's what I will do on Monday. Here's my long, more detailed plan. So on Wednesday, which is April the 21st, we will do 10.4b and then 11.1. Next Monday, which is 26, we'll do continue with 11.1 and 11.2. And on the Wednesday, we will do 11.3, 11.4. But I need you to watch the video though, okay? I need you to watch the video so that I can just focus with working on the problems. Okay, see you then on Wednesday.